Hello students, welcome to this lecture on surface areas and volumes. Okay, so in today's lecture we will discuss exercise 12.1. Okay, so in our previous lecture there we have studied surface areas of solids. Okay, and in this lecture we will start from exercise 12.1. So student, note it down. If we do not give the value of phi, then in that case you can take the value of phi is equal to 22 by 7. Okay, so you should keep on your mind the value of phi is equal to 22 by 7. Okay, so unless stated otherwise you can take phi is equal to 22 by 7. And sometimes you may give the value of phi is equal to 3.14. Okay, so that case you should use that value. Otherwise you can take pi is equal to 22 by 7. So let's get started from question number 2. Okay, so in question number 2, here we have a vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. The diameter of the hemisphere is 14 centimeter and the total height of the vessel is 13 centimeter. Then find the inner surface of the vessel. Okay, so basically we have given a vessel which is in the form of a hollow hemisphere mounted by a hollow cylinder. Okay, and we have given the diameter of the hemisphere is 14 centimeter and the total height of the vessel is 13 centimeter. Okay, so let us find the inner surface area of the vessel. So how to solve it? Let us see how to solve it. So first of all, draw the diagram. So if you draw the diagram, then you will get the diagram look like this. Okay, so here this portion is hemispherical part and this portion is cylindrical part. So it can be observed from this diagram that radius r of the cylindrical part and the hemispherical part is the same. Okay, and we have given here the diameter of the vessel is 14 centimeter. Okay, and now the radius of the cylindrical part and the hemispherical part is actually 7 centimeter, that is half of the diameter. And now height of the hemispherical part is basically is equal to the radius of the hemispherical part. And here the radius of the hemispherical part is equal to 7 centimeter. Okay, so the height of the hemispherical part is equal to 7 centimeter. And now height of the cylindrical part. So we need to find height of this cylindrical part. And here we have given in this question the total height of the vessel is 13 centimeter. Okay, so now if we subtract 7 centimeter from the total height of the vessel 13 centimeter, then you will get the height of the cylindrical part. Okay, so height of the cylindrical part h is equal to 13 minus 7, that is equal to 6 centimeter. Okay, and now inner surface area of the vessel is nothing but the curved surface area of the cylindrical part plus curved surface area of hemispherical part. Okay, so if we add curved surface area of cylindrical part and curved surface area of hemispherical part, then you will get inner surface area of the vessel. Okay, so inner surface area of the vessel is equal to curved surface area of the cylindrical part plus curved surface area of hemispherical part. And student, we know curved surface area of cylindrical part is nothing but 2 pi rh, where r is radius of the cylindrical part and h is the height of the cylindrical part. Okay, and we know that curved surface area of hemispherical part is equal to 2 pi r square, that is where r is the radius of the hemispherical part. Okay, and here in this problem we already find the value of r, that is radius of the cylindrical part and height of the cylindrical part and radius of the hemispherical part, that we have find already. So now we can put these values in this formula, and then we'll get inner surface area of vessel is equal to 2 times 22 by 7 times 7 plus 6 into 6 plus 2 into 22 by 7 into 7 into 7. Okay, so now if we simplify it, then you will get this is equal to 44 times 6 plus 7, and this is equal to 44 times 13, and this is equal to 572 semi square. Okay, so now therefore the inner surface area of the vessel is equal to 572 semi square, and this is the final answer. And now let us move to question number 3. So in question number 3, here we have a toy is in the form of a cone of radius 3.5 centimeter mounted on a hemisphere of same radius, and total height of the toy is given to us 15.5 centimeter. And here we need to find the total surface area of the toy. Okay, so this toy is of the is in the form of a cone of radius 3.5 centimeter and surrounded and mounted on a hemisphere of same radius. Okay, so first of all we need to draw the diagram, and then from that diagram we can easily we can observe that the radius of the conical part and the hemispherical part is same. Okay, that is 3.5 centimeter. So now height of the hemispherical part is basically equal to radius of the hemispherical part, that is equal to 3.5 centimeter. Okay, and you can write 3.5 centimeter as 7 by 2 centimeter. Okay, now height of the cylindrical part, height of the conical part h, this is equal to actually total height of the toy minus height of the hemispherical part. Okay, so here the total height is 15.5 centimeter, and the height of the hemispherical part is 3.5 centimeter. So now height of the conical part h is equal to 15.5 minus 3.5, that is equal to 12 centimeter. Okay, so here we get the radius of the hemispherical part is 3.5 centimeter, and the height of the hemispherical part is 3.5 centimeter, and radius of the conical part is 3.5 centimeter, and height of the conical part is equal to 12 centimeter. And now let us find total surface area of the toy. Okay, so before finding the total surface area of the toy, here basically we need to find the slant height L, okay, of the conical part. So we know this formula, slant height L of the conical part, this is equal to square root of r square plus h square. Okay, so we know this formula. So now if we put the values of r and h, then we will get the slant height L. This is equal to actually square root of 7 by 2 square plus 12 square, and this is equal to square root of 49 by 4 plus 144, and this is equal to square root of 49 plus 576 divided by 4. Okay, and this is equal to square root of 625 by 4, and this is equal to 25 by 2. Okay, so slant height L of conical part, this is equal to 25 by 2 centimeter. And now total surface area of toy, that is actually equal to curved surface area of conical part plus curved surface area of hemispherical part. Okay, so here the curved surface area of conical part is pi RL, where R is radius of the conical part and L is slant height of the conical part. Okay, and we know curved surface area of hemispherical part, that is 2 pi r square, where r is the radius of the hemispherical part. Okay, so now if we put the values of r, L, okay, then we will get this is equal to 22 by 7 into 7 by 2 into 25 by 2 plus 2 into 22 by 7 into 7 by 2 into 7 by 2, and this is equal to 137.5 plus 77, and if we add them, then you will get this is equal to 214.5 centimeter square. Okay, so total surface area of the toy is equal to 214.5 centimeter square. Okay, so now let us move to next question. So in next question, here we have a cubical block of side 7 centimeter is surrounded by a hemisphere. Okay, and what is the greatest diameter of the hemisphere can have, and find the surface area of the solid. So in this problem, we have given a cubical block of side 7 centimeter and is surrounded by a hemisphere. Okay, so first of all, you need to draw the diagram. Okay, so if we draw the diagram, then you will get look like this. Okay, so this is the diagram of cuboid block surrounded by a hemisphere. Okay, so in this problem, basically we have to find the greatest diameter of the hemisphere can have, and we need to find the surface area of the solid also. Okay, so let us find. So from this diagram, it can be observed that the greatest diameter possible for such hemisphere is equal to the cube's edge. And here in this problem we have given cube's edge, that is equal to 7 centimeter. Okay, so from this figure here, the greatest diameter possible for such hemisphere is equal to 7 centimeter. Okay, and now radius of the hemispherical part this is equal to 7 by 2, this is equal to 3.5 centimeter. Okay, and now total surface area of solid, this is equal to surface area of cubical part plus curved surface area of hemispherical part. Okay, so surface area of cubical part plus curved surface area of hemispherical part. So here we know the surface area of the cubical part is 6 times h square. Okay, and here area of base of the hemisphere part, here area of the base of the hemisphere part will be removed. Okay, so here total surface area of the solid will be 6 times h square plus 2 times pi r square minus pi r square, and this is equal to 6 times h square plus pi r square. Okay, so total surface area, this is equal to 6 times 7 square plus 22 by 7 into 7 by 2 times 7 by 2. Okay, and this is equal to 294 plus 38.5, and this is equal to 332.5 centimeter square. Okay, so total surface area of solid, the total surface area of this solid, this is equal to 332.5 centimeter square. Okay, and now let us move to next question. So in next question, here we have a hemispherical depression is cut out from one face of a cubical wooden block such that the diameter L of the hemisphere is equal to the edge of the cube, and determine the surface area of the remaining solid. So basically we have given a hemispherical depression which is cut out from one face of cubical wooden block, and such that the diameter L of the hemisphere is equal to the edge of the cube. Okay, and we need to determine the surface area of the remaining solid. So let us find. So here, if first of all you can draw the figure. So this is our figure. Okay, so this solid is basically combined of cubical block and a hemispherical part. So here first of all, the diameter of the hemisphere, this is equal to edge of the cube, and we have given the edge of the cube is L. Okay, so diameter of the hemisphere, this is equal to L, and now radius of hemisphere, this is equal to L by 2. So now total surface area of solid, this is equal to surface area of cubical part plus curved surface area of hemispherical part. And here we have to remove the area of base of the hemispherical part, that is not included in the surface area of the solid. Okay, so basically here we have to remove the area of the base of the hemispherical part. So now total surface area of solid, this is equal to 6 times h square plus pi r square minus pi r square, and this is equal to 6 times h square plus pi r square. Okay, so total surface area of solid, this is equal to 6 times h square plus pi r square, and here we have given edge of the cubical block is equal to L. Okay, and here we find the radius of the hemisphere is L by 2. Okay, so total surface area of solid, this is equal to 6 times L square plus pi times L by 2 whole square. Okay, and this is equal to 6 times L square plus pi r square, pi L square by 4, and this is equal to 1 by 4 times 24 plus pi times L square unit square. So the total surface area of the solid is equal to 1 by 4 times 24 plus pi times L square. And now let us move to next question. So in next question, here we have a medicine look like this. Okay, so in this medicine capsule is in the shape of a cylinder with two hemispheres. So here you can see here at ends of this capsule, here we have a two hemispherical portion. Okay, so here we have given the length of the entire capsule is 14 millimeter and the diameter of the capsule is 5 millimeter, and we need to find its surface area. Okay, so you can visualize this figure. So this is our capsule. Okay, this is our medicine capsule, and here the length of the capsule is 14 millimeter and the diameter of the capsule is 5 millimeter. Okay, now you can observe that radius of the cylindrical part, this is equal to radius of hemispherical part. Okay, so radius of cylindrical part and radius of hemispherical part are equal. So radius r of cylindrical part, this is equal to radius r of hemispherical part, and here we have given diameter of the capsule is 5 millimeter. Okay, so radius of cylindrical part is equal to radius of the hemispherical part, this is equal to 5 by 2 millimeter. And now length of the cylindrical part, this is actually equal to total length of the capsule minus length of the hemispherical part. Okay, so here length of the entire capsule is 14 millimeter and the length of the hemispherical part is 2 times radius r. Okay, so here this is equal to 14 minus 5, that is equal to 9 centimeter. So height of the cylindrical part h is equal to 9 millimeter. And now surface area of capsule, this is equal to 2 times curved surface area of hemispherical part plus curved surface area of cylindrical part. Okay, so we know that curved surface area of hemispherical part is equal to 2 pi r square and curved surface area of cylindrical part, this is equal to 2 pi r h. Okay, so now we put the value of curved surface area of hemispherical part and curved surface area of cylindrical part in this formula, then we'll get this is equal to 2 times 2 pi r square plus 2 pi r h. Okay, so this is equal to 4 pi times 5 by 2 whole square plus 2 pi into 5 by 2 times 9, and this is equal to 25 pi plus 45 pi, and this is equal to 75 millimeter square. Okay, and this is equal to 70 into 22 by 7, that is equal to 10 into 22, that is equal to 220 millimeter square. Okay, so surface area of capsule, this is equal to 220 millimeter square. Okay, so here we able to find the surface area of the capsule, this is equal to 220 millimeter square. And now let us move to next question. So in next question, here we have a tent is in the shape of cylinder surmounted by a conical top. Okay, if the height and diameter of the cylindrical part are 2.1 millimeter and 4 meter respectively, and the slant height of the top is 2.8 meter, then find the area of the canvas used for making the tent. And we also find the cost of the canvas of the tent at the rate of 500 rupees per meter square. Okay, so in this problem basically we have a tent. which is in the shape of a cylinder surmounted by a conical top. And we have given some information like height and diameter of the cylindrical part are 2.1 meter and 4 meter respectively, and slant height of the top is 2.8 meter. Okay, so first of all we need to find the area of the canvas used for making the tent. Okay, and then we also find the cost of the canvas of the tent at the rate of 500 rupees per meter square. Okay, so note that the base of the tent will not be covered with canvas. Okay, so the base of the tent will not cover with canvas. So let us find. So let us solve it. So first of all, draw the figure. So this is our figure. So this portion is a cylindrical portion, and this is our conical part. Okay, so here we have given the diameter. We have given the height of the cylindrical part is 2.1 meter, and diameter of the cylindrical part is 4 meter. So radius of cylindrical part is 4/2, that is equal to 2 meter. Okay, and slant height L of conical part is 2.8 meter. Slant height L of conical part is 2.8 meter, and now area of canvas used, that is equal to curved surface area of conical part plus curved surface area of cylindrical part. Okay, so curved surface area of cylindrical part is equal to pi RL. Okay, and curved surface area of cylindrical part is equal to 2 pi RH. Okay, so curved surface area of conical part, this is equal to pi RL, and now we can put the value of RL, okay, and H. So here the value of R is for value of the radius of the conical part is 2, okay, and the slant height is 2.8, and for the radius of the cylindrical part is 2, and the height of the cylindrical part is 2.1 meter. So here area of canvas used, this is equal to pi times 2 plus pi times 2 into 2.8 plus 2 pi times 2 into 2.1, and this is equal to 2 pi times 2.8 plus 2 into 2.1, and this is equal to 2 pi times 2.8 plus 4.2, and this is equal to 2 times 22/7 into 7, that is equal to 44 meter square. Okay, so area of canvas used, this is equal to 44 meter square, and now we need to find cost of 44 meter square canvas. Okay, so we have given cost of 1 meter square canvas is equal to rupees 500. Okay, and we need to find the cost of the 44 meter square canvas is equal to, that is actually equal to 44 times 500, and this is equal to 22,000. Okay, so cost of 44 meter square canvas is equal to 22,000 rupees. Therefore, it will cost of rupees 22,000 for making such a tent. And here the base the base of the tent will not covered with canvas. Okay, so when we are able to find the area of the canvas used for making the tent, and that is equal to actually 44 meter square. Okay, and we have given cost of 1 meter square canvas, that is equal to 500 rupees, and then cost of 44 meter square canvas is equal to 44 times 500, that is equal to 22,000. Okay, so therefore it will cost of rupees 22,000 for making such a tent. So now let us move to question number 8. So we have in this question, from a solid cylinder whose height is 2.4 centimeter and diameter 1.4 centimeter respectively. A conical cavity of the same height and same diameter is followed out, and now find the total surface area of the remaining solid to the nearest centimeter square. Okay, so let us find. So if you draw the diagram, then you will get this figure. Okay, so here given that height of conical part H is equal to height of the cylindrical part, that is given to us 2.4 centimeter. Diameter of the cylindrical part is 1.4 centimeter. Okay, then therefore the radius of the conical part radius of the cylindrical part is equal to 0.7 centimeter. And now slant height L of conical part is equal to square root of r square plus h square, that is equal to square root of 0.7 square plus 2.4 square, that is equal to square root of 0.49 plus 5.76, and this is equal to square root of 6.25, and this is equal to 2.5. Okay, total surface area of the remaining solid will be curved surface area of cylindrical part plus curved surface area of the conical part plus area of the cylindrical base. And here we know the curved surface area of cylindrical part is 2 pi rh, curved surface area of conical part is pi rl, and area of the cylindrical base is pi r square. Okay, so the total surface area of the remaining solid will be 2 pi rh plus pi rl plus pi r square. So this is equal to 2 times 22 by 7 into 0.7 plus into 2.4 plus 22 by 7 into 0.7 into 2.5 plus 22 by 7 into 0.7 into 0.7, and this is equal to 4.4 into 2.4 plus 2.2 into 2.5 plus 2.2 into 0.7, and this is equal to 10.56 plus 5.50 plus 1.54, and this is equal to 17.60 semi square. Okay, so total surface area of the remaining solid to the nearest semi square is 18 semi square. And now let us move to question number 9. So in question number 9, we have a wooden article was made by scooping out a hemisphere from each end of a solid cylinder as shown in this figure. Okay, if the height of the cylinder is 10 centimeter and its base is of the radius 3.5 centimeter, then find the total surface area of the article. Okay, so let us find. So radius of the cylindrical part is radius of the hemispherical part, that is equal to 3.5 centimeter. Height of the cylinder part h is equal to 10 centimeter, and surface area of article is actually curved surface area of cylindrical part plus 2 times curved surface area of hemispherical part, and this is equal to 2 pi rh plus 2 times 2 pi r square. Okay, and now if we put the values, then we'll get 2 pi into 3.5 into 10 plus 2 times 2 pi into 3.5 into 3.5, and this is equal to 75 plus 49 pi, and this is equal to 119 pi. And if we now put the value of pi is 22 by 7, then you will get this is equal to 17 into 22, that is equal to 374 semi square. Okay, so this is all about this lecture. Thank you very much to all of you.